In this video, we are going to demonstrate how to build a bond beam and movement joint using core-fill high-R units, using what is called a Michigan-style joint. The advantage of this approach is that it allows us to build the joint without sacrificing the thermal properties of the pre-insulated core-fill high-R units, as we would have to do if we used conventional masonry units at the movement joint location. Core-fill high-R is a pre-insulated masonry wall system that offers thermal values that are far superior to traditional concrete masonry, while still delivering the considerable thermal mass benefits of concrete masonry. Typical R values for high-R are 4 to 5 times higher than conventional masonry. Let's discuss how to build the bond beam with these units first. One of the benefits of the high-R insulated wall system is that it is designed to accommodate both horizontal and vertical grout placement for reinforcement without removing the insulation inserts. The high-R units are used to form the bond beam with a few simple modifications. The first course of our demonstration wall will be knockout bond beam units, which are made by saw cutting the webs of the core-fill high-R units so that the top portion of the webs behind the insulation can be removed to reduce the height of the cross webs to accommodate the placement of steel reinforcement rebar. We are also demonstrating how to build a movement joint in the bond beam course using high-R units. We lay the first course of high-R masonry units, which will be the bond beam. Knockout high-R bond beam units are laid and leveled on this course. The core-fill insulation comes pre-installed in the units. As each course is laid, the insulation should be pressed down into place so that it is snug with the crosswebs in the unit. A couple of basics here regarding the high-R system. When placed correctly, the top of the units will have the insulation insert spanning the entire length of the unit, as shown here. The insulation inserts each have two offset parts, and these will form lap joints with the insulation in adjacent units, both to each side and above and below. To ensure optimal insulation performance, the mason should take care that the units are placed so that the insulation in each unit is flush and tight with the insulation inserts in adjacent units. The next step is to remove the knockout portions of the webs in the bond beam course with a hammer to accommodate placement of reinforcement rebar. Due to the pre-cuts, these will remove easily. At the movement joint location, we are going to want to break bond of the grout in the bond beam so that the joint can function as a means of accommodating any slight movement that may occur in the wall. To do this, we are going to place a sheet of material at the joint to break the bond of the grout. The break material is cut to fit the joint, and a hole is cut into it to accommodate a sleeve that will surround one element of the rebar in the bond beam as it passes through the joint. The bond break is placed in the joint. Dual runs of rebar will be placed in the bond beam. On one side, the rebar will not pass through the joint, but will terminate at either side of it. On the other side, a sleeve is placed adjacent to the bond break, and a continuous strand of rebar will pass through this sleeve. This design allows a structural rebar connection through the joint, while the sleeve will allow that connection to accommodate a slight amount of movement. The bond beam is then filled with grout up to and on both sides of the bond break at the movement joint. Bond beams form a horizontal barrier and could become a collection point for any moisture that reaches the cores of the wall. For this reason, we are going to install a flashing and weep system above the bond beam to allow a means for moisture to drain to the exterior of the wall. We are using the block flashing and weep system here. The units are placed above the bond beam. These units combine a pan that will collect moisture with a weep spout that will cross through the mortar joint to the exterior of the wall and provide the moisture a path to drain. Additional courses of high-R units are laid above the flashing system. For end units, the high-R units have been cut to size, and the units are placed so that the overlapping portions of the insulation inserts will fit together as normal. The mortar bed is placed along the course with the flashing units just as it would be normally. Care should be taken, however, to clean out the weep spouts of the flashing units after the mortar joint is in place and is being tooled so that no mortar blocks the spouts. We will need half units at the joint location. Here we show high R units that have been saw cut in half, being placed on each side of the joint. The units are placed so that the insulation inserts with offset ends are placed to form a lap joint of the insulation with that of the adjacent units. We are also demonstrating in this small demonstration wall the use of spec brick high R. Spec brick high R is a half-high architectural masonry unit that combines the blended colors of spec brick with the pre-installed insulation inserts of Corfill high R. These units, while offering the aesthetics of brick, are installed in the same manner as full-height Corfill high R units and will offer the same benefits in terms of enhanced thermal performance. The cores of the units at the movement joint will be grouted above the bond beam, but on one side of the joint, bond breaking material will be placed so that the joint can accommodate movement in the wall. This will produce a joint that is both weather-resistant and tolerant of slight movement. After the wall is laid, the movement joint will be sealed using a suitable masonry joint sealant for weather protection. There are other methods of building movement joints using sash units with insulation inserts, but these may involve some reduction in the thermal insulation properties of the wall at the joint location. Using a Michigan-style movement joint, as we have demonstrated here, is a great way to maintain the superior thermal properties of the high R system by using the high R insulated units right up to the movement joint itself. For more information, please visit our website at concreteproductsgroup.com or send questions to info@concreteproductsgroup.com.